Then I went to the clouds.
Okay.
And then to the ground.
Okay.
And then to the aquifers.
Okay.
To the ground.
Okay.
Then back to the atmosphere.
Okay.
Then back to the ground.
Okay.
And then to plants.
Okay. Thank you. So this is how the Jess water molecule in particular flowed through the biosphere. Andrew, let's hear it from you.
So I started at snow,
Snow.
went to the atmosphere,
Okay.
and I stayed in the atmosphere the next 3 times.
1,
And
2,
then I went back to the clouds,
3. Clouds.
or to the clouds,
Okay.
then back to the atmosphere,
Okay.
and then back to the ground.
Back to the ground. Cool. All right. So that was Andrew, the water molecule. Thank you. Anushka, you're up.
I started in rivers and lakes,
Rivers and lakes. Okay.
to the aquifer,
To the aquifer.
back to rivers and lakes,
Back to rivers and lakes.
stayed there,
Stay there.
went to the ocean,
Oh, look at you diversifying.
the atmosphere,
The atmosphere.
stayed in the atmosphere,
Okay.
clouds,
Okay.
snow,
Okay.
and then back to rivers and lakes.
Back to rivers and lakes. Killing me. All right. Cool. So there's Anushka. Whoa. The water molecule. That was dangerous. Bijan.
So I started at aquifer,
Aquifer. Okay.
then went to rivers and lakes,
Okay.
then went to the ocean,
Okay.
then went to the atmosphere,
Okay.
stayed in the atmosphere,
Okay.
went to the clouds,
Okay.
went to the snow,
Okay.
then rivers and lakes,
Okay.
then oceans,
Oh my goodness. All right.
then atmosphere,
Okay.
then clouds,
Okay.
ground,
You're very active.
aquifer,
Okay.
ground,
Okay.
plants,
Plans. Oh.
and then atmosphere.
All right. Okay. Thank you, Bijan. You were all over the place. Appreciate you. Gary.
Started in the atmosphere,
Okay.
and then went to the clouds,
Okay.
went to the oceans,
Okay.
and then to the atmosphere,
Okay.
and then stayed in the atmosphere,
Okay.
went to the ground,
Okay.
atmosphere,
Okay.
clouds,
Okay.
ocean,
Ocean. Let's go around there.
stayed in the ocean,
Okay.
stayed in the ocean,
Okay.
went to the atmosphere,
Okay.
went to the ground,
Okay.
went to the atmosphere,
Okay.
went to the ground,
Okay.
went to the atmosphere, went to the ground.
Okay. Cool. Where did you start? I forgot.
Atmosphere.
Atmosphere. Interesting. So you ended up kind of like cycling back through this pattern at the end. That's pretty cool. And lastly, but not least, Heather.
Atmosphere to clouds,
Okay.
to ground,
Okay.
to atmosphere,
Okay.
to clouds, to ocean,
Ocean.
to atmosphere,
Atmosphere.
to ground,
To the ground.
to the atmosphere, to the ground.
Okay. This really crazy mess is our hydrological cycle in cells. Okay? This is really complicated. This is also not perfect, right? Let's really quickly think about 2 opportunities. So 2 different volunteers, 1 opportunity each, where this doesn't match real life. There's 10,000 different ways, but let's think of 2 right now. Yes, sir?
Like glaciers exist in real life.
Glaciers exist in real life. In our model, they actually don't exist, right? So if I hadn't written this up here, we would have been totally cool. Didn't need those cards either, right? That's a really, really good observation that you made. What's one more?
There's some like direct connections missing, unless I'm not seeing things correctly.
What's one example?
Like I think clouds and rivers and lakes aren't directly connected, and I think snow and oceans are directly.
Yeah. How could clouds and rivers and lakes be directly connected in real life?
Oh, I don't really know.
You had it on your initial model.
Condensation.
Yeah.
I mean, not
Well-
evaporation.
Yeah.
Yeah.
Sorry. So condensation was actually the one that doesn't really apply. It could be evaporation, going this way, or it could also be what?
Precipitation.
Precipitation going back down,
Yeah.
right? So the water cycle that a lot of us learned in elementary school is pretty simple, right? It kind of looks like this. That's an arrow, I promise. So it's kind of like the recycling sign, right? It's 3 arrows. They're going in one order, in a fixed order. But life is really chaotic, right? So our simulation with 6 water molecules showed us this. Not perfect, right? As you guys pointed out 2 examples, but there's also a lot more complexity in what the water cycle might look like versus our traditional understanding, right? So what we're actually going to do right now is I want you to flip back to page 1. So one thing that we actually did, right, is we developed a model based on our own prior knowledge and based on, for Bijan, making some really astute observations, right, making a prediction that maybe those words that your teacher has written on the board might actually be worth something, right? Pretty good. What we're going to do right now is I'm going to go back to that initial timer, and I want you to take 4 minutes to think about your model and also think about this. Right, and using a different color of ink, whether now this is a different pen or a different marker, I want you to revise your model. Now, obviously we're not erasing anything, right? Because like I said, every single thing that you had on there initially was true. This simple water cycle can exist, right? But it's actually, in real life, has a lot more parts than that. So what I want you to do is revise your model, and we're going to take 4 minutes to kind of deliberate on this. Revising your model could look like a bunch of different things. One could be drawing additional stuff. A second thing could be scratching something out and representing it in a different way. A third thing could be making a comment to describe something, right? Just making some notes on the outside. A fourth example I can also think of is asking some questions. Right? Because this hasn't solved all of our hydrological cycle questions, right? Or all of our problems. It's just provided us with some more evidence. Okay? So if you have any questions, statements, or additions or subtractions, now is the time to include them. Does anybody have any questions? Okay. Go ahead and get started with those 4 minutes again. When we create our models, they can't be perfect representations, right? It's never going to be perfect, and that's totally okay. But what I do want to see evidence of is you using information that we learned together to revise your prior understanding. That's how I know you're engaged. Do you mind if I take a picture of your work so I can share it with the class?
Sure.
Thanks. your very basic understanding, which we'll get into more later, is essentially it's an underwater reservoir, underground reservoir water.
Oh, that makes sense.
It's kind of like a lake underground. Andrew, what do you think about that?
Yeah, lake underground and side rock, permeable rock.
Yeah.
I thought it was underground plants. I was like, that
I
doesn't
knew
make
it was
sense.
something underground. I wasn't sure what.
So because I see about half of you guys finished, let's just cut this time short. We're going to do 30 more seconds. Okay.
It's a good thing I wasn't a major.
But you haven't gone to college yet.
Maybe I should.
There you go. I'm glad you're thinking about your future.
Maybe you should be a biology major now, or geology,
Environmental science.
or you should be a teacher.
Math classes.
I could see being a teacher.
All right, guys. So let's come back together really quick. I want everybody's eyes on the board in 5, 4, 3, 2, 1. Okay, cool. So I apologize, I have to sit over here. But let's look really quickly at Jess's model. Okay. Jess, what was your original, not original, that's not a word. What was your original color that you used?
Blue.
Right, and we had you explain earlier. Could you explain really briefly again what you were thinking with the blue?
That the clouds were raining in onto the mountain, and then the river was going down the mountain into the ocean, and then back up into the clouds. And
Okay,
I
cool.
forgot about the ground until the last part.
Totally cool. So, you made some revisions, right? Tell me about your revisions, and we'll start from the top of the page and go down, because we can't see it all at once.
Well, I added the atmosphere because I forgot about that part in the first go around. And then I redirected some of the arrows, especially seeing how everything changed and would go different directions all over from jumping back and forth. And I also added a glacier because I wanted to. And then the ground because I'd kind of forgotten about the whole process of the aquifers and the water going up into the surface. And I added a lake and a person. Well, he was already there.
He's got a little hat. He's ready. Must be the Alps or something.
Yeah.
So I have one question for you, then I want to see if the class has any questions. We had talked really briefly while you guys were revising your models about aquifers. So if you were to actually put the label aquifer somewhere on here, where would you like to put it?
I put it.
Oh, you did, because I took your picture
There were a
afterwards.
few updates after he took the picture. I put the aquifer underneath.
Interesting.
Is that right?
What do you guys think? Andrew, what do you think about what Jess said?
Aquifer. Well, I'm not totally sure, but I think it has something to do with water in the ground.
Okay.
So I think being near the ground part would probably make it correct.
Yeah, I totally agree. Okay. Does anybody have any questions for Jess based on now her initial model or her revisions? All of your models look different, right? There's changes in all of them, and you all chose to approach this in slightly different ways, which is totally cool. Okay? What we're going to continue to do as we go through this unit is add in more information so that we can make this initial model even more complete throughout the course of the next 2.5, 3 weeks or so. Okay? You can stop taking